We're going to wrap up with 3 last examples where we're mixing all of the exponent rules together. There are many approaches to these depending on the order that you happen to notice an exponent rule, but you will get the same answer no matter which order you decide to apply those exponent rules in. I usually like to start by looking at something like this as 2 separate problems. I would use the fraction on the left first and simplify as much as I could there. The only thing I can do here is that I know x cubed divided by x to the first is x squared by using my division rule, my quotient of powers rule, where I keep the same base and I subtract the exponents. 3 minus 1 is 2. So I'm going to rewrite that first fraction as 3x squared y over 4. And now I'm going to move on to my second one, and I can do the same thing here with the y's, where I'm doing y squared divided by y cubed, and that would be the quotient rule again, and 2 minus 3 would be negative 1. So when I simplify the second fraction, it would be 12x squared times y to the negative 1, and then there is no denominator left, so I could just put over 1 if I would like, since the y cubed has already been accounted for. Now from there, I'd use one of my things that I remember from elementary school about multiplying fractions, and that is that if I want to multiply fractions, I multiply straight across the numerators to get a new numerator, and then straight across the denominators to get a new denominator. So I'm going to use the numerators first, and I'm going to think of this as almost as 3 mini problems. I'm going to look at the constants, the x's, and the y's separately. So first I'll look at the constants, 3 and 12. 3 times 12 is 36. And then next I'll move on to the x's. I've got x squared times x squared, and that is my product of powers property, where I keep the same base and I add the exponents. So I'm keeping the x and I'm adding 2 plus 2 and getting 4. And next I could move on to the y's, where I have got y times y to the negative 1. Now of course I do remember that if there's no exponent it's like a 1. So I've got y to the first times y to the negative 1, and that is my product of a power again, where I keep the same base and add the exponents. So I'll keep the y, and I'll do 1 plus negative 1, which is 0. And I still need to multiply across the denominators yet. 4 times 1 is 4. Alright, next thing I would do is look at just my constants. I can simplify that part. I can do 36 divided by 4, and that reduces to 9. Then I still have the x to the 4th and the y to the 0. And for my last step, I'll remember my rule about 0 exponents, and that is that anything raised to the 0 power always equals 1. And I also know my identity rule from the beginning of the year, anything times 1 equals itself. So my final answer here would be 9x to the 4th. Okay, let's try another one. Same idea. I'm going to work with the first fraction and simplify that, and then I'll move on to the second one. So for my first fraction, I see the y to the negative 1 in the bottom. I'm going to use my rule about negative exponents where they switch positions. So the y is going to go to the top of the fraction and become a positive 1. Since there's nothing left over in the denominator after I move the y, I can put it over 1 if I want, just so it's still written as a fraction, but I wouldn't necessarily be required to do that. Now I'm going to move on to my second fraction, where I've got a quantity raised to the negative 3rd power. This is like the power of a quotient property, where it reminds me of distributing. Both the numerator and the denominator are going to get that exponent. So the numerator becomes x squared raised to the negative 3, and the denominator becomes y raised to the negative 3. Now I'm going to continue to work on that second fraction. I'm going to leave the first one alone for now. I'm going to continue to work on this second fraction. Here I've got a power raised to a power. And I remember that that rule is where you keep the same base. So I'm going to keep the x, and then I multiply the exponent. So I do 2 times -3 and get -6. And while I'm here, I'm also going to remember that in this denominator, I've got a negative exponent. That's the one where it switches positions in the fraction and becomes a positive exponent. So it's going to move to the top and become a positive 3. And since there's nothing left in my denominator, I could think of that as a 1. Right. Next, I'm going to use what I remember from elementary school about multiply fractions, where I multiply the numerators and then multiply the denominators to get a new numerator and a new denominator. And I'll split this up as like separate mini problems here. First, I'm going to work with the x's. I've got x, which is x to the first, times x to the -6, and that is my product of powers rule. And I know that if I multiply two powers, I keep the same base, and I add the exponents. So I keep the x, and 1 plus -6 is -5. And then I'm going to do the same thing for the y's. I'm going to do y to the first times y cubed, which is y to the fourth. And the denominator would be 1 times 1, which is 1. And I'm just about finished here. I've got a negative exponent, which I know switches positions and becomes a positive exponent. So the y to the fourth stays where it is because it does not have a negative exponent. But the x to the -5 goes to the bottom of the fraction and becomes a positive exponent. So then my final solution is y to the fourth over x to the fifth. All right, one last problem. I've got 2x squared y over 3x times 9xy squared over y to the fourth. Right. I'm going to end up rewriting this in a different location, but I'm going to start with this first fraction, and I can see that I can simplify my x's first. This is my quotient of powers rule, where I keep the same base and I subtract the exponents. So I'm going to keep the x, I'm going to do 2 minus 1 and get 1. So I'm going to end up with an x to the first, and I didn't touch the 2 or the y or the 3. Now I'm going to move over to the second fraction, and I can use the same property on the y's. I have got y squared over y to the fourth, so I'm going to keep the same base, which is y, and I'm going to subtract the exponents. 2 minus 4 is -2. Now I didn't do anything with the 9 or the x, so that's going to remain the same. Since there's nothing left in my denominator, I'm going to write that as a 1. Next, I'm going to multiply my fractions, multiply the numerators to get the new numerators, multiply the denominators to get the new denominator. So, treat this as separate problems. First, I've got the constants. I've got 2 times 9, which is 18. I've got x times x, which is x squared. And I've got y times y to the -2. This is my product of powers rule, where I keep the same base and I add the exponents. So I'm going to keep the y. I'm going to do 1 plus -2, which is -1. And then in the denominator, I've got 3 times 1. And I'm just about done here. I can do 2 more things. I can simplify the 18 over 3 and come up with a 6. And I can take my negative exponent and move it to the bottom of my fraction. So then my final solution, I'm going to write this over here, would be 6x squared over y. Technically it would be to the first power, but remember we usually don't write a first power.